What's up, guys? Welcome to my 16th, I believe, PyGame tutorial. And in this tutorial I'm going to be going over how to calculate the distance between 2 points. Now I got my little drawing thing open to show you guys visually because I found out that it was a lot easier if you guys could see. So in my last tutorial we had 2 points, one at 2025 and one at 4055. So if we went over 20 and down 25, let me put 20, 25. Wow, I got pretty good handwriting on the screen. And then we went over 40 and down 55. So over 40, down 55. So I'll put this at 40, 55. And we already built a function to calculate our vector, which was 20, which is the difference between the x, and 30. So let me go ahead, and here would be our vector right here, and you can calculate that because the difference is let's see, it's 20 down and 30 across. So our vector would be 20, 30. So now that we have our vector, we need to calculate the value or distance of this line right here. So if you're wondering, alright, I know what a vector is, I know how to calculate the coordinates of the vector, but I need to figure out the distance from point A, which is here, to point B. So let's go ahead and do that right now. And by the way, since this is a right triangle, the formula for this is a squared, and this side equals b squared, and this slope, this would be c squared. So a squared, I'm not even going to type it, plus b squared equals c squared. So that's what we're going to do. This is called Pythagorean's theorem, and he gave this to us because he wanted us to make computer games. So that's what we're about to do, and that's what I'm about to show you how to do. So let me minimize out of that. And we already got one function. Actually, I'm going to go ahead and change this to x and y. X, y, x, y. Let me run it, make sure it still runs, make sure I didn't break anything. And 2030, there you go, still runs. So now that we figured out this formula to go ahead and build the vector, we need a formula to figure out the distance. So let's do that right now. Let's make another function in our class, in our vector class, and this time let's name it distance. So def distance, and make it self. And what we need to do is first set the variable of the side A and the side B. So we already have we already have a list up here, and the first item in the list is the difference in the first side, and the second item in the list is the difference in the second side. So the first item in the list is this right here, and the second item in the list is this right here. So we can utilize those variables that we already got in our formula down here. Man, would you look at this? I really messed up. That's like graffiti right now. Anyways, so we can use that list to extract the values from it to, well, it's a lot easier to see. So let's go ahead and set two variables for the side so it's easier to see. Self A, I don't know why I said A twice, but this is equal to self diff 0. Since this is equal to this coordinate minus this coordinate, so right now self A is going to equal 20. Because remember, here's the list I was talking about. This list is self diff. So self A is going to be equal to the first item in it, which is 20, and self B I'm going to make is equal to this item, which is 30. And then we can use those two items, these are the two sides, and we can use these two sides to figure out the length of that third side. So let's go ahead and write self B and set it equal to self diff, and this would be 1. Since, remember, 0 is the first item in the list and 1 is the second item. It's weird, but that's the way it is. And now we need something called a math function square root. So what we need to do is import math, and this will give us the use of the square root function, which will give us the ability to solve for that third side. So what we want to do is return math dot square root, and again what we need to put in here is a squared plus b squared. So go ahead and put self dot a asterisk asterisk that 2, and that means square root in Python. You probably should know that. Self b asterisk asterisk 2. And what this pretty much means, it's a really complicated way of writing it, but a squared plus b squared and equals c squared. In order to get c squared, we need to take the square root of it. So that's what this does right now. So let's go ahead, and the last thing we have to do is print out our answer. So print thing dot distance, and it doesn't take any parameters. As you can see, it only takes the self parameter. So let's go ahead and run this, and then after it works, I'll show you guys it one more time. So here are the two sides. This side is 20 going up and down. The side going left and right is 30, and the distance between those is 36. So let me show you in my awesome, here we go, right here. This side would be 20, this side would be 30, and this side would be 36, the sloped side. And again, if you take this side squared plus this side squared, it equals this side squared, and that's how you get it. And it's a lot easier if you know that theorem, but anyways, that's how you do it. So let me talk you guys through this one more time. What we did is we took this list that we already built. We already knew the first item in the list was the length of the first side. The second item in the list was the length of the second side. So all we needed to do is square those, square A and square B, and then you got the square root of the slope side, or excuse me, the distance of the slope side. And then we just printed it out. So that's your quick tutorial on how to find the distance between 2 points using a vector. It makes it really easy, thanks to Pythagoras or whatever his name is. So practice this tutorial, follow along with me. Don't forget to change your variables, and also don't forget to import math, or else you won't be able to use the square root function. So again, thank you guys for watching. Don't forget to subscribe, and I'll see you next tutorial. What's up guys, welcome to your 17th PyGame game development tutorial, and in this tutorial I'm going to be going over something called a unit vector. Now I drew this little diagram because I thought it was easier to show you guys what's going on instead of just talking about it, since it can be kind of confusing. So I'll review what we did so far. The first thing we did is we build a coordinate at x, and that's this. We built it at 20, 25. The next thing we did is make a point at y, which was at 40, 55. The next thing we did in this initialization function is created a vector, or found out what the difference was between x and y. So we subtracted x from y, and we got 20, 30. And this is because 40 minus 20 equals 20, that's a change in x, and 55 minus 25 is 30, that's a change in y. So the vector from x to y equals 20, 30. So that's how we got that. So that's all this initialization function does, is give us our vector. And next we needed to calculate the distance. So we know from Pythagoras that this is side A, this is side B, and in order to solve for side C, we just use a squared plus b squared equals c squared. So we took a, squared it, b squared it, and we got the square root of that, and that gave us our 36. So this is the vector, and this is the distance. 36 is the distance. But now what I'm going to be teaching you guys is something called a unit vector. What a unit vector is, if it pretty much says, alright, if instead of 36, if that distance wasn't 36 but it was 1, and that's where the name unit comes from, because it's only 1, then what would this vector be? So what we're going to be doing in this tutorial is taking that 36, changing the distance into a 1, and finding the vector from that. It's not going to be 20, 30 anymore, it's going to be a lot smaller. So let's go ahead and do that right now. In order to do that, let me position this. We first need a new function, and I'm going to name mine unit. So put def unit self. And now what we need to calculate this, let me show you guys how to calculate this. In order to calculate the vector, what you do is take the side of A and put it over the distance. And in order to calculate the y unit vector, take the y side and put it over distance. So 20 over 36 and 30 over 36. So let's go ahead and do that. The first thing we need is a variable for the distance. So we'll write distance equals, and this is equal to self distance. Since we already found that out in the last tutorial, no need to do it again. You just can't write 36 because and when you're making programs, these coordinates might be different, and we want this to work all the time. So that's why you need to do that. So in order to get the A unit, or the side, how am I going to say this? In our new vector unit we're building, we're going to need a new variable for both the sides. So let's go ahead and make a new variable. A unit, which is going to be the new A side, and we'll set this equal to, remember I told you guys the formula is that side A over distance. So now we divided A by distance, and it gave us that new variable A unit. So now we have to do that for B. Self B unit, that's my street name, self B, which is that side B, over distance, which is the hypotenuse of that triangle. And now all we need to do is return something, because every function needs to return something or else it's useless, unless it prints something out. But that's another story for another day. So return self A unit and self B unit. Make sure I spell it right. Looks good. So now that we returned it, all we need to do is print it out. So let's go over here and print thing unit, and this should work. Hopefully it does. Cross your fingers. And let's go ahead and save this. And look at this. Here's what we printed out so far. The first thing we printed out was our vector. The next thing we printed out was our distance, which was 36 point something. I was too lazy to include that. In the new vector, hypothetically, if the distance was 1, it would be this. This would be the change in x, and this would be the change in y. So again, one last time, what we did is we pretty much took that side A and we divided it by the distance, or the hypotenuse, and this gave us a reduced version of, if that was 1, what would the new side equal. And we did that same for B. We took 30, divided it by 36, and that gave us our answer of 0.8. So again, that's your quick tutorial. The easiest way you can learn this is just follow along and type it all in yourself, and after you type it in, I'll promise you'll understand a lot better what it does. So for now, that's your quick tutorial on unit vectors. Again, these are going to be extremely useful. You cannot program 3D graphics if you don't know what unit vectors are. And again, in these next couple tutorials, well, probably in like a few tutorials from now, we're going to be developing 3D graphics for our game. And if you don't know what unit vectors are, you're not going to be able to add that 3D dimension. So this is very important. So again, thank you for watching. Learn your vectors, stick to these tutorials, and soon enough we'll be making some sweet 3D graphics. So don't forget to subscribe, and I'll see you next tutorial.